Hello class, good morning to Alpha. Can you hear me? Sound check.
Good morning, teacher.
Yes, good morning to you too, Rachel. I hope others can also hear me. Yeah. Okay, my screen presentation. Can you see as well? Can I? Can you see my presentation? Who are you? Okay, who are you? Okay, thank you very much. All right. So I think we can continue the lesson for today. Last time we already discussed the current, voltage, and resistance in series circuit. Okay. Make sure you identify the type of series circuit and then their formula. Okay, how to calculate the current, how to calculate voltage and resistance in series circuit by using the formula that I already taught you last class, previous class. Okay, sorry for the interruption. Okay, make sure you understand how to calculate, how to calculate the current, voltage, and resistance in series circuit. All right. So next one, the advantage and disadvantage of series circuit. I think you can read it for yourself. There are a few advantage and disadvantage when you are using the series circuit for your electrical setting. For example, number one, the advantage for number one, every component in the circuit receives the same amount of current. Okay, because if you still remember the formula or the calculation for current in series circuit, all equal. Okay, meaning that total current equal to current number one and current number two. This one, current I mean I is current. Okay, equal to I1 and equal to I2. Okay, so we have a same amount of current in the series circuit. Okay, so number two, what is number two? Every component is controlled by the same switch. Just wait for a moment. I want to open this one. Okay. All right. Okay. Okay. This is an example of the advantage and disadvantage of series circuit. For the series circuit first, if I can draw the schematic diagram for series circuits like this, okay, so this is an example of series circuit. So we have here, for example, the battery and then battery connected to the ammeter, for example here, and then the ammeter connected to the bulb over here, and then the bulb is connected to the switch. This is the simple, what we call the simple series circuit. Okay, series circuit. Right. So number one, advantage number one, all right, every component receives the same amount of current. Okay, for example here, if the current reading is, for example, 0.5 ampere, all right, meaning the current on the first device, the I1 over here is also 0.5 ampere. And then the current received by the second device, we call it I2 over here, is also receiving the same amount of current. Okay, so if I put another component, okay, inside the series circuit, and then the amount of current also the same. Okay, this is the first advantage. Can you understand, class? Is that okay? All right, very good. So number two, every component is controlled by the same switch. Okay, if you look at the series circuit, my drawing on the series circuit over here, the first device, I call it bulb number one lah, yeah? Okay, I call it, this one is the bulb number one, and then this is bulb number two. Okay, both what we call component, okay, both component what we call can be controlled by one switch. If you can see here, I am just using only one switch. One switch here. Okay, I just using one switch here, and then if I open of if I turn on the switch, both bulb will be what? If I turn on the switch, both bulb will be light, or it will be lighted or it will be turned off. Both. Okay, never mind. I just close this first. All right. If I what we call close the circuit, for example, right here. If I can close the circuit, for example, right here. Okay, meaning that the circuit is complete, right? Can you see here? The circuit is complete. What happened to the bulb? If I turn on the switch, both bulb will be light. Yes, correct. Both bulb will be lighted. Okay, when I turn on the switch. By only one switch, by using only one switch, I can control all the component here. I can control all the device. The device here, it's example, the bulb. Yeah? The first bulb, B1, and the second bulb, B2, I can control it by only one switch. Okay. Advantage number three, increase in voltage supplies. Increase in voltage supplies more electric current. Okay. Increase in voltage supplies. Increase in voltage supplies. Increase in voltage. Okay. Increase in voltage supplies more electric current. Okay. For example, if I add another battery here. Okay, if I add another battery here, for example, I add another battery here, okay, and then the amount of current from 0.5, for example, maybe will become, for about just estimation only, maybe increase to 1.0 ampere. Okay, so B1 and B2, what happened to B1? The current on B1 and B2, is it same or different? If I add another battery and then the amount of total current is 1 ampere, so B1 is also same, yeah, meaning that B1 is also 1.0 ampere and then B2 also 1.0 ampere. Okay, this is the advantage of series circuit. Okay, now let's see the disadvantage of series circuit. Number one, when one of the electrical appliance is damaged, other electrical appliance cease to function. Cease to function here meaning that the others appliances cannot function. Cannot function. Cease to function meaning cannot function. For example, I will show you what happened. Right. I just erase this for a moment. Okay. For example, there is a problem. For example, there is a problem with bulb number 2. Okay. Bulb number 2 is damaged. Right. Bulb number 2 is damaged. Okay. Maybe why? Maybe the circuit or the filament inside the bulb is what we call is broken. Okay. Bulb number 2 is damaged. So what happened to bulb number 1? If I turn on the switch, bulb because of the damage in bulb number 2, what happened to bulb number 1?
No front.
Okay, bulb, okay, very good. If there is a damage in bulb number 2, the bulb number 1 cannot function as well. It is not because bulb number 1 is damaged. Bulb number 1 is not functioning because bulb number 2 here is damaged. Damage here may be the circuit here. Okay, the circuit, the filament inside the bulb here is broken. Okay. Do you know the what we call the inside bulb? Inside bulb there is a filament. There is a filament like this. Okay, this is bulb. Inside the bulb there is a filament. Filament here will turn on and then give us the light energy. And then sometime when the temperature is too high, when the what we call the heat is too high, sometimes the filament here will be broken. Will be broken. This is the bulb. Sometimes the filament will be broken, and you can see by your observation, we can observe the filament here is broke, is cut off, just like this. Okay. Okay, you can see here it's already broken. So when there is broken, the electrical current cannot go through the filament. So if B2 is broken or damaged, B1 is not receiving any current. It is not receive any electrical. So B2 damaged, no light. B1 is not damaged, but because there is no electricity, B1 also do not light. Okay, it is not we know it is not function because there is no electric. All right, can you understand this disadvantage number 1? Okay. All right, so disadvantage number 2, adding more electrical appliance increases the resistance and decreases the current, decrease the flow of the current. When you add, okay, what is meaning by that? Okay. All right. Okay. Disadvantage number 2, adding more electrical appliance increase the resistance and decrease the flow of the current. Okay. Decrease the flow of the current. Decrease the flow of the current or decrease the flow of voltage. Yeah. Not a current. Yeah, I think decrease the flow of the voltage. Yeah, not the current. Not the current. The current is same, right, class? Can you help me over here? Is it true, the disadvantage number 2, adding more electrical appliances increase the resistance, yes, and decrease the flow of the current. Is it true? Because the formula for current in series circuit is I equal to I1 equal to I2. Is it true? Decrease the flow of the current. The current will be all the same, right? Is it decrease the flow of current or decrease the flow of voltage? Which one do you think the correct one? Current or voltage here? Current or voltage, you think? My class? Any answer? Current? Okay, current or voltage? Because in series circuit, the current, the current on the series circuit remain all the same. Okay, I total over here equal to I1 equal to I2. But if you are looking at the formula again, voltage equal to voltage 1 plus voltage 2. Okay, do you still remember the how to calculate the current voltage on series circuit? You must remember this one lah. You must remember this one. Okay, so meaning that, okay, right, if I use, for example, this one 1.234, okay, this one is about, for example, 3 volt. Okay, never mind. For example, we have three battery, we have 3 dry cell here, and then the voltage, the total voltage for the battery here is about 4.5 volt. Okay, 4.5 volt. Right? And then what is the voltage for V1? What is the voltage here for V1? And then what is the voltage for V2? Divide it by, you just divide it by 2, right? Because we have only 2 components, right? So V1 is how much? 2.25. Yes, 2.25 volt, and then V2 also 2.25. Okay, because according to the formula here, total voltage equal to voltage 1 plus voltage 2. Because we have only 2 components here, bulb 1 and bulb 2, so you just divided 4.5 volt, the total current for the battery, you just divide it by 2. Because we have only 2 devices here. Okay. Again, go to the disadvantage number 2. Adding more electrical appliance increase the resistance and decrease the flow of current or voltage over here. Which one is the correct one? The current or voltage?
Voltage.
Voltage, yeah. Actually, it is a voltage. Never mind if I got mistake. If I make mistake, I will correct it later on. But according to my understanding, voltage is what we call decreasing. Voltage is decreasing because the voltage here, if there is, if we put more component, the voltage will become less. Will decrease. Okay. Disadvantage number 3. Each electrical appliance cannot be switched off individually. Okay. Meaning that you only use one switch. One switch, you want to control all the appliances. You cannot at the same time. You want to turn on bulb number 2, for example, but you want to turn off bulb number 1. Is it possible in series circuit? Bulb number 2, you want to be light up. Bulb number 1, you do not want to switch it on. Possible or not possible in series circuit? Can or cannot in series circuit?
Cannot.
Yes, you cannot individually control the component. Okay, because in series circuit, you only use one switches. one switch control all, one switch control all in series circuit. So if you want to control individually, meaning that maybe you want to turn on the bulb number 2, but and you want to turn off bulb number 1, you must use parallel circuit later on. Okay, any problem with this? Advantages and disadvantages of series circuit. Is it okay?
Okay.
Okay, thank you very much. Next one, Okay, next one, current, voltage, and resistance in parallel circuit. Make sure you understand and identify the diagram or the circuit, the schematic diagram of the parallel circuit. I think you already know that. And then the formula is over here. This is the formula of how to measure current, voltage, and resistance in parallel circuit. Okay. Alright. So this is parallel circuit. P-A-R-A-L-L-E-L-C-R-C-U-I-T. Parallel circuit. Okay. Example of parallel circuit is like this. Okay. Just draw it for you. You have two cell. Okay. And then we have switch, for example, over here, and then we have the component over here, and then we have component number 2 over here, and then maybe I just another one. Oh, no need lah, I just use 2 component only. I just use 2 component only. I just use 2 components. Okay. So this is the what we call the parallel circuit. Okay, parallel circuit. Can you identify the loop? How many loops? There are 2 loops, right? Because we are arranging the component, the bulb here, into parallel, not series. Okay. So, what are the how to measure the current inside the inside parallel circuit? So, if you can refer here, total current equal to current number 1 plus current number 2. Current number 1 plus current number 2. Meaning that if the total current here this is ammeter. Example, if the total current is I total, okay, I T. T mean here total lah, You can also put T over here. Okay. If the ammeter, okay, this is ammeter. If the ammeter reading is, for example, 2.0 ampere. Okay. If the total current of the parallel circuit is 2.0 ampere, so what is the current for I1 and I2 on the bulb? What is the current here?
1.0.
Okay, very good. 1.0 ampere for bulb number 1 or I1, and also for second bulb I2 is also 1.0, because according to the formula according to the how to measure the current on parallel circuit is I total equal to I1 plus I2. Okay, is it okay, class? Do you understand this? Can right? Okay. Can class? Okay. So if I draw the ammeter here, this is another ammeter, and then this is another ammeter here. So the reading on ammeter 1 and ammeter 2, both reading is about 1.0 ampere. Okay, and then the whole circuit over here for parallel circuit, the measurement of current is 2.0 ampere. Okay, can class boleh Very good. Okay. Now, how about the voltage? Voltage very easy lah class Voltage is very easy. For voltage here, all the same, simple. Just opposite the series circuit. Opposite the series circuit only. For example, the total amount of the dry cell here is about 1.5, 3 volt, 3.0 volt. The total voltage here. Okay, the total voltage here is about 3 volt. Okay, so now okay. So what is the voltage for bulb number 1, V1 and V2? Very simple, very simple. V1 is
3.0.
3.0 also, yes. And then V2 is also? Look at the formula here. V2 also, V2, how much V2? Also 3.0, yes, very good. And if I add another component here, I add bulb number 3. So V3, I label it as V3. So what is the voltage for V3?
Also, same.
Also?
2.0.
Okay, very good. Also 3.0. Yeah. So meaning that the voltage in parallel circuit all the same. Okay, the voltage is all the same. Okay, you understand it? Okay, good. Right. So number 3. Number 3 is the resistance. Right, number 3 is the resistance. Okay, number 3 is the resistance. Where's your textbook? Okay, resistance, right? 1 over R equal to 1 over R total equal to 1 over R1 plus 1 over R2. Okay, right. So if the resistance of the first bulb here, R1 resistance, if R1 resistance over here is 1 ohm, R2 is 2 ohm. So what is the total resistance for the circuit? Anybody? Okay, the first one is 1 over 1 plus 1 over 2. Okay, so how do you want to do it? What is the answer? Anybody?
Three over two.
Yes, 1 over. So what is the total resistance in parallel circuit? 1 over 2. 1 over 2 ke? Berapa jawapan? Berapa jawapan? You must add the what we call fraction, right? The addition of fraction. Okay, never mind. Later you try to calculate it yourself. So this is how I just want to show you how to calculate the resistance in parallel circuit. Must include the fraction lah, yeah. One of the half the fraction on the R1 and R2 here. Okay, if you want to get the total resistance in parallel circuit, you must use this formula over here. Okay, class? Can, So what is the answer?
3 over 2.
2 lah, 0 over 2. Oh, okay. Never mind. Later you can try to calculate later. Okay. What happened here? All right. So, advantage and disadvantage of parallel circuit. Again, advantage and disadvantage. Sorry. Parallel circuit. Okay. Advantage and disadvantage of parallel circuit. Oh, very big one here. Okay. Parallel circuit, advantage and disadvantages. Okay, so I delete this first. All right. Okay. Okay, advantage number 1. Every electrical appliance can switch on off separately. Can you understand this? Every electrical appliance can be switched off and on separately because we have, according to the parallel circuit in my drawing here, in my schematic drawing, we have two components, bulb number 1 and bulb number 2. Meaning that bulb number 1 and bulb number 2 can be controlled separately by using the switch here. Okay, this is the switch also, right? This is also switch. Okay, but I call this main switch or master switch, meaning that if I turn off this switch, both bulb 1 and bulb 2 will not light up. Is it true? Right. If I turn this off, bulb 1 and bulb 2 simultaneously or at the same time, it will not be lighted. So, how can I control the individual component? In this case, the bulb 1 and bulb 2. So, I need to put what, class? Where do I need to put the switch in order to control bulb 1 and bulb 2 separately? So, my solution is I can put the switch in here. Can you see it, class? I can put switch here. Right? So now I have two switch. This is what we call the individual switch. Switch number 1 and switch number 2. Right? So if I want to if I want to turn off bulb number 1, if I to turn off bulb number 2 and I want to keep bulb number 1 lighting, I just do it like this lah. See? So now bulb 1 is is on and then bulb 2 is off. This is what we call by every electrical appliance can be switched on or off separately. You understand it? Can class, huh? Boleh tak? Okay, very good. Right. Okay, number 2. Advantage number 2, the increase in total of electrical appliance does not affect the function of other appliances in the same circuit. The increased number of electrical appliances do not affect the function of other appliances in the same circuit. So bulb 1, different what we call individual circuit. Bulb 2 is another individual circuit. That's why, like I said earlier, before this, it has 2 loops. Okay, this is the first loop. If I can draw it again, this is the first loop, right? And then this is the second loop. This is for what? This is for parallel circuit. Okay, meaning that the increased number of electrical appliances does not affect the function of other appliances in the same circuit. Individual. Okay. Disadvantage for parallel circuit, the voltage for every appliance cannot be adjusted because the voltage is the same as the source of the voltage. The voltage cannot be adjusted. This is the advantages of what we call the parallel circuit. For example, if the total voltage here is what? Total voltage here is about 3 volt. Okay, 3.0 volt. And then B1, how much is B1? What is the formula? You still remember the formula? B1 is how much? How much? Yes. How much is how many the voltage of B1?
1%.
1 volt or what? Class. This is parallel. This is parallel. Okay. According to the textbook, V total equal to V1 plus not plus. Plus or equal class? Equal, yes, V2. So, if the total voltage is 3 volt, so V1 is also 3.0 volt, and then V2 also 3.0 volt. So, the voltage for every electrical appliance cannot be adjusted because the voltage is the same as the source of the voltage. Voltage is the same. This one same. Okay. Voltage is the same as the source of voltage. This is the sources. This is the sources of voltage. And then this is the appliance voltage, meaning it all must be in the same voltage. Okay, class? Is it clear?
Yes.
Okay, very good. So, all right. Okay, numerical problem related to the current, voltage and resistance in series circuit and parallel circuit. I think later on I will try to give you some of the sample exercises for you to calculate the current, the voltage and the resistance in both series and parallel circuit later on. Okay. How about your workbook? Got any calculation how to calculate? Oh, okay, you got the calculation here. Okay. Okay, never mind. I will try to give you the exercise later on our Telegram group. So again, if you have any question, you can ask me on our Telegram group also. So I think I will stop the lesson here. I will stop the class here. See you all again on tomorrow lah ya. Tomorrow we have class at 9:15 lah. I will start at 9:15 in the morning tomorrow. Okay, I will give you the exercise later and the answer for our previous workbook later also, right? Okay, class. I think we can stop here. Thank you for your cooperation. Thank you for your participation. Now I pronounce it correctly. Okay, and focus. See you all again all tomorrow. Okay, you can leave the class now. Goodbye. Bye bye.
Thank you, teacher.
Bye bye. Thank you.
Bye-bye.
Bye.